Awesome. I'm going to start. So my name is Vishal Singh. I'm the head of data products at Starburst. Uh, Starburst is the data lake platform organization built on open source Trino. We are able to connect through all your data across different sources, and you can search, query, and govern all your data sets using Starburst. With us today, we also have Fahad. Fahad is our one of our customers who works at Halliburton, and we hear from Fahad how Halliburton is transforming their data lake swamp into data products that provide near real-time insights by adopting Starburst products. Fahad, would you like to speak a few words about yourself?
Yeah, thanks, Vishal. So I'm Fahad. Can you guys still see me and hear me okay?
I can hear you, Fahad, but your video camera is probably off.
Oh, sorry. Okay. Yeah, I'm Fahad. I lead data science at Halliburton Digital Solutions. So Halliburton is, oil and gas service company. We provide services which span across the entire life cycle of an oil well. And I'll talk a little bit more about our journey and our partnership with Starburst. But I'll hand it back to Vishal.
Thank you, Fahad. I'm really excited about talking about what we're building at Starburst and how Fahad is using at Halliburton. Next screen. So, what is Starburst Data Products? Before we go into data products, I would like to talk about Starburst in general. Starburst is a data lake analytics platform where you can access all your data across all your sources in and around a lake. We also bring a unique Stargate connectivity, which provides you access to data across different regions, across cloud, and between cloud and on-prem environment. With Starburst, you can secure and govern all your data set while managing access, privacy, encryption, as well as things like monitoring and logging. Starburst is built on the open source Trino query engine. We have added significant proprietary features here as well, like warp speed, which allows you to get the query response time similar to an optimized data warehouse. As part of the engine, Starburst offers fault-tolerant execution, which means long-running queries and complex transformation jobs, and not fail without out-of-memory limitation. Finally, we have modeling and semantic layer, including data products, which includes all the features you need to build, organize, share data products with the standard SQL. The reason we went on the data products journey, and I think Fahad will talk more about it, is poor data quality impacts decision costs and trust in the organization. If you look in the organization, the data products is being produced by data producers and consumed by data consumers. And data producers could be a data team, it could be an analyst, or it could be anyone, or data consumers can also be another data team who are consuming data products from different organizations or across different business units or a team. Between data producers and consumers, there's always a question. Data producers like, how do I produce and deliver reliable data to my consumers? While I'm doing this, how do I maintain trust with my stakeholder? How do I reestablish trust? And how can I proactively maintain the trust around the data? Data consumers, does data sets look good to use? How do I know where the data has been used? Who is using the data? Is this data still good to use? And who should I actually ask any questions if I have questions around the quality or any other questions around the data set itself? That brings to the point the Starburst data product is a data product platform for data organization that need to rapidly connect consumers with the high quality and reliable data sets. With data products in Starburst, you are able to discover, create, and publish, manage, and share data products based on multiple data sets. Your data can belong to a warehouse, Snowflake, Lake, MongoDB, Elasticsearch, SQL, Postgres, but you can completely streamline visibility across all the data set and consume and curate the data, which can be produced in more of a marketplace experience, which can later be consumed by your data consumers. As a data producers, you can quickly understand the users metrics and create and publish and find managed curated data sets. You have a consistent governance on the data set, which means you're securing the data with the column level, row level, and different access control, where you can provide different views of the data to different users based on the groups or roles or persona they come from the organization. And ultimately, you are providing the data products that can be accessed with the trust and which has been approved for frequent business use case, because data products are meant to be repeatable and meant to be accessed and consumed across the organization. Fahad, to you.
Okay, thanks, Vishal. So yeah, let's let's talk a little bit about Halliburton and how we went through this journey where we collect a lot of data, but it was very difficult to actually extract insights from data. So like I said, Halliburton is a 100-year-old company, global organization. Um, we have, internal business units. We call them PSLs, product service lines. So we have 13 PSLs, and the way they operate, they collect data, the data formats, how they store data, how they use data. It's very, I would say, different from each other. And so the problem was, 4 years back, and Vishal, if you can go to the next slide, please. Um, 4 year backs, we set on this journey. We started on this journey of, we'll build this central platform, data lake, which will basically collect data from all these disparate sources into a central location, so that people can consume it and use it, right? So again, this slide, it's a little busy, but all it's saying is that we have some operations happening at different remote locations all over the world. Whether it's drilling, fracking, like I said, it's the entire life cycle of an oil well, right? We have hundreds of sensors attached to our equipments, which are collecting and streaming data in real time. And all this data, it first comes to the cloud, Event Hub or other, streaming messaging queues, but eventually it lands into this central data lake. We call it the Halliburton data universe. So that was the strategy 4 years back, that we'll collect all the data, and hopefully people will start consuming the data more and start making more data-driven decisions. The problem with this, like I said, is it's a very big company. A lot of things happened over the years in terms of let's say mergers, acquisitions. So we have new groups joining in, and then they have their own systems. So all this made it extremely difficult for a central team to manage and make sense of the data. So next slide, please. So all the challenges that come with a centralized data lake, especially for a very big organization like Halliburton, right? We have 13 smaller companies within a big company. The biggest problem, I would say, would be the third bullet point here in the third box, which was, the central team was always overburdened because we have, multiple data producers and multiple data consumers, right? So there was always this, confusion about who is responsible for the quality of the data that is in the data lake, right? Because we have, obviously we have data scientists. I lead data science, but we have, a lot of domain experts like, chemists, geophysicists, and, petrophysicists who make use of this data every day. They analyze the data. They even though their day job is not a data science job, they still use data for everything that they do. And for them, it was really difficult to go from raw data to a acceptable quality of data that they can use for this for their analyses, right? And then this, like I said, there was ambiguity who takes that responsibility, and the central team, because of such a large scale and volume of data, they were not able to support it. And then the next thing was that I would like to highlight is there was no control on quality and integrity, and which is true for everyone. Raw data is never, you have duplicates, you have missing values, especially for high frequency sensor data, right? There's so many things that can go wrong. So someone has to take that and curate it, and obviously the central team was not able to handle the workload. So this was the state, I would say, 4 years back, right? So then we started working with Starburst, I would say about 2 years back. And then our main goal with the partnership with Starburst was to make a query engine or a query layer available to all our consumers, so that like I said, we have data scientists, but we have other analytical folks who want to analyze data. So we wanted to make it easy for them to connect their BI tool, or even Python, MATLAB to different data sources in the company, and start consuming those. So that was our primary goal at that time. So next slide, please. But we realized that even though we made that possible, it was the other problem. So we have an easy way to access the data, but there is still this problem of the quality of the data. And that's when we started, I would say 6 months back, we started on this journey of data products, right? How can we build instead of one central team managing both the I would say storage as well as the quality of the data. Instead of that, we need to move towards this decentralized data management, right? So as everyone knows, data mesh is basically talks about domain-driven data ownership, right? So we built this domain. So if you see here, this is just one example view of how a data mesh inside Halliburton looks like. So we have 13 PSL. So we started aligning our domains with the PSLs, right? So, and each PSL would be responsible for creating, owning, and maintaining, their data products, right? So if you see here, and the central bubble, the yellow bubble is the infrastructure that my team owns and maintains. So think about, let's take for example, right, one of the domains. So you'll have people from that domain who will take ownership, and they will create data products. And when they create data products, they'll make sure, the data product is of high quality, it's reusable, all the good things that come with the data products. The data products themselves, or the data themselves, right, with the mesh architecture, doesn't have to be moved to a central location. The data can live wherever it was in disparate sources. So if you see the small icons, I have put there, the data can come from Azure storage as Parquet files, or it can come from a relational database, SQL Server or Oracle somewhere. It can even come from a different cloud. We are mostly on Azure, but it can be on AWS, right? Cassandra, MongoDB. So different disparate data sources. Data mesh basically provides this abstraction layer or logical layer where, for the consumer of the data, you don't have to worry about where the data is coming from. The producer basically, when they create the data product, it becomes a contract that, hey, I'm surfacing something that might be useful to you, and I'll make sure that it's all the guarantees that I give, those are always honored, and you can just consume it, right? So on the right, we see these purple boxes where there's everyone gets a single point of access, a consistent view of the data, right? So you have your data scientists, you have your ad hoc queries, your BI and reporting, and finally, you can build software applications, web apps, which consume the same view of the data. So that's in a nutshell how the data product ecosystem inside Halliburton looks like. So, and then next slide, please. So then what happened was, obviously this is good. We have a mesh now, we have a few good quality data products, people have started consuming it. And then ChatGPT came along, and then we saw a big opportunity where, for this ad hoc query piece, right, where I was saying someone can go and write SQL and query the data and get an answer. We saw an opportunity that why not just use, large language models to help with that process too. So for example, let's have our users query or write queries in natural language, just plain English. We'll use the schema of the data product, we'll use the query, and then we'll use a large language model, in this case Azure OpenAI, to convert that English queries into SQL. And now, since we have a nice curated data product interface, we can take that SQL query and call the Starburst API and run the SQL query against the data product and get the answers in real time. So this is the, in a nutshell, the architecture of the system that we built on top of the Starburst data products framework. So next slide, please. So how it looks like, right? So we have an internal data mesh portal. So this is not the homepage, but when you go to the homepage, you'll see like, very similar UI to what you see in Starburst today on the data products page. It has this curated, nicely described, a tile of products, data products. So you can go and search for things. Each tile is, one data product which talks about what it does, what was the lineage, where did it come from, all those things, right? And once you click on a tile, it basically brings you to a page something like this. So this is one example data product, right? We have created for one of our PSLs, and then it has several curated data sets inside it. So again, I won't go into too much detail, but think about like sensor data which is coming, which is getting stored while drilling, right? So when we are drilling an oil well, there's lots of equipments and sensors which are capturing data, and then we basically stream it to the cloud and store it here. So once we store it here, once we come to this interface, right, as you can see, it actually makes it very easy for someone to ask ad hoc questions of the data. So just one example, how many unique wells are using iCruise? iCruise is a rotary steerable system used in oil and gas industry for directional drilling, like when you are drilling a deviated well. And so to get the answer right, before it used to take easily, I would say 2 to 3 weeks, because someone would have to go to a data scientist would have to fish for the data, try to find it, and then write some code, Python or a Spark, and then combine all those data sets, and then run some queries or aggregations and come back with an answer. And it was completely not extensible, because someone can ask a slightly different question, and again, you had to spend a lot of time going through the same process again and again. With this, since we have a nice curated view, we can just ask a question and get an answer back in like 2 seconds. So this is just an example, right? So you go from natural language to a SQL query. OpenAI helps us there. Once you have the SQL query, you have a nice data product interface through Starburst. You just run the SQL query against the data product, get an answer back. So that's just one example, but completely extensible. You can ask whatever you want. You can play with the prompts. You can, if you don't get the answer you desire, you can, tweak it a little bit and make sure that, the SQL that, and you can see the SQL also here to make sure that the SQL is running fine or looks fine. Next slide, please. So yeah, so this has been an interesting journey. We started this because I lead data science, right? So we were on this journey where we wanted to make uh, the work that my team does more efficient, right? Because we were spending a lot of time in just making sense of the data, connecting to different data sources, cleaning the data, combining them. And then along this journey, we realized that the system that we are building can easily provide benefits to the entire organization. So it's been interesting how we went from trying to do something which was more selfish to kind of arriving at something which is now beneficial to the entire company. And this is one of the messages that we our senior VP of technology just put it in the team's chat, which is he called me one day and asking about if I'm doing something with large language models. And then I started explaining, before LLMs, let me try to explain this concept of data mesh. And then I gave him a demo, and you can read through the message, but he clearly liked it, what he saw, and it made sense to him. And it also, one of the things I realized was this concept of data mesh and data products. Sometimes it can be a little abstract, but the fact that we built a very accessible and easy to use interface where someone can go and just ask questions, right, in plain English and get an answer. And that's when we saw that step change where people realize that this all makes sense, right? Distributed data management, and then connecting them through a central point of access, and then asking ad hoc questions and getting back the answers. So to conclude, right, the benefits, right? So we have been very happy, working with Starburst and the platform that we have built. Now we have a system where anyone in the company can get instant access to any data and start asking questions of the data. We have gotten rid of all this brittle data movement pipelines. Like I said, it's a mesh, so you don't have to really move the data and centralize it. Centralization is encouraged, but it's optional. A lot of times you can't centralize everything. We can still use the mesh architecture and connect to different data sources wherever they are. And then as you saw in the demo, we can easily go and ask questions. It's gets you an answer in 2 seconds. So it's really allowing or enabling fast data-driven decision making. And one thing I want to just quickly also add is the platform allows you to incrementally scale, right? So you don't have to think about, hey, I'll build my mesh for 2 years, only then something can be useful. You can actually start, and that's the beauty of the data mesh, right? You can start with a few initial good quality data products. They don't have to be anything fancy, just very simple things. And then give it to your consumers. Start, they can start consuming it, asking questions, building dashboards, or doing data science. And you can incrementally build from there. So that's the power, that you don't have to wait for 2 years to have something which is useful. You can have something beneficial within a couple of months. We have really seen the benefits with this strategy. So that's the presentation. I want to thank you all for listening, and we'll open for Q&A, I guess.
Thank you, Fahad, for all the insight. While we wait for any Q&A, question from my side. I think the great insight which you gave is how gradually you went on creating some basic data products then to full scale. How did you choose what the first few data products to build in the organization?
Yeah, good question. So the first few data products obviously came from my reviews with executive leadership. When I used to go and present or talk about some data science project, they used to ask me this ad hoc questions, right? And I couldn't give them the answer. I was like, okay, give me 2 weeks, and no one is going to wait 2 weeks for an answer these days, right? So that's how we kind of took a note of all these questions that were coming, and we thought there should be a better way. Instead of asking them to wait for 3 weeks, we should have a system where they should be able to go and ask questions and get answers immediately. So that's how we started with the data products journey.
Absolutely makes sense. You have to please the execs first to make sure they're happy on the journey you're on. Another question, as we're waiting for more questions, is um, um, how do you see the difference over the time? So before Starburst and after Starburst, how has your workload changed with the Starburst data products coming into the organization?
Yeah, I mean, definitely, data science team wants to do advanced, data science work, right? We were getting bogged down with all these ad hoc things that people wanted. And like I said, my team, we have a small team, and instead of working on some cool, new things, innovating new things, we were more working as like a BI analyst who would take a question and then look at the data and answer those questions, and then next question will come in, right? So it was a very inefficient process. So we clearly see big improvements, right? Initially, yes, it takes time to build a nice curated data set, but once you are at that, I would say, tipping point where you can answer a few questions, you will see exponential benefits, because it's like extensible, right? Any other questions which you had not even thought about before, now you can come and ask those questions and you can get an answer. So we have clearly seen huge efficiency improvements, much less work in like taking ad hoc questions and working on those and answering those. Rather, we just let people go and ask whatever they want once the data product is created and curated.
Absolutely makes sense. There's a question on chat by Greg. The question is, do you have any point of view whether it is helpful or necessary to govern, detect, avoid a coupling across the system, building an even bigger monolithic or hairball? Love to hear your thoughts, but I'm going to add my own opinion after your thoughts.
So, I mean, that's one of the things that data products allow is, this hierarchy of data products, right? So you can start with, foundational data products, and then you can go to next level, which is like a data product which consumes data products, or combines data products and builds another data product on top of it. So that's how you can keep it structured. I mean, Vishal, what's your thoughts?
No, I absolutely agree with you. I mean, one of the great pieces that in the monolithic structure, what happens is if something breaks, everything breaks.
Yes.
See, that's why it's monolithic. With data products, there will always be a part of any code. There will always be a problem. There will always be issues. But how can we ensure that problems and in the part of creating data products is the blast radius is small, so that no other processes in the organizations are not impacted? And that's why it's really important to, when as a part of data products using Starburst, you can actually empower every team, as you have done for Hard in your organization, to create their own data products while still maintaining the quality, but seeing the complete full lineage into where the quality has broken, which one should I avoid, even understanding the metrics into which data products is used at what time, and so. Again, was there any question? Sorry, I heard something. If not, then one more, Fahad. This is something which I have seen over the time in the data products. Actually, there's a question here. I'm gonna use that. Do you use Starburst or your mesh against other platform, ETL, ELT, CDC copies of data? Also run it against transactional system that are source of records? How do you control load against the later?
We don't use any other data platform per se. I mean, but we do connect our mesh to, operational data sources like SAP and surface those. We haven't seen any problems with the load or anything like that. I don't know, Vishal, have you seen this with other customers?
There could be, but I'm going to explain that this is why Starburst provide the different ways of accessing the data sets. So in fact, we have with Starburst, because of the Trino, as like goes to the Trino open source, we have in fact sometimes seen a better performance with the Starburst because it can access data directly in some cases. But if you want to avoid the load on your source data sets, the Starburst data products can either be views, which is where you are accessing directly the source data set, or you can materialize the data into object storage. So instead of creating the load on the source data set, you can frequently keep materializing the data in the object storage. So as if your data can be refreshed every hour, every 5 minutes, or every once in a day based on how often you're going to materialize it. So you can completely avoid the load into the source data set and use a materialization feature, which is completely configurable to give users a sense that data is coming from raw source.
Yeah, we have, just to add on that, now that you mentioned, I remember, yeah, we do use materialized views. So we have our sensor data, and then we have a failure information in a different database. So we materialize that so that, that join, right? We don't want every query to run that join again and again. It's very inefficient, right? So we do the join once, materialize it, and the materialized view refreshes once daily, right? In the night, sometime. So it's very effective technique.
Awesome. Before any last comments, Fahad, before we call it?
No, I'm very happy with Starburst, and thanks for everyone for joining today and listening. If there's any further questions, feel free to talk to us or contact us.
Awesome. Thank you, Fahad. Likewise, again, if there are any questions, reach out to us. Visit starburst.io. We also have the Galaxy platform, which you can sign up for free and enjoy all the capabilities. So if there are any questions, reach out to us directly. I'm on LinkedIn, but reach out on starburst.io. Thank you.
Thank you.